This is your starting point. All right? So you're comparing everything to that, pretty much. All right? So we're starting there. What changed from here to here? Well, they instead of having 56 plus 0, they just wrote it as 56. What tells me that 56 plus 0 keeps 56 the same number? The identity property. You add 0 to any number, it does not change the identity of the number. So from here to here, all they did was use the identity property to replace 56 plus 0 with just 56. Everybody see that? Next thing, what did they do? Well, they just rearranged these two, right? It was 79 plus 44, and then they wrote 44 plus 79. What property says that if it's addition, I can just rearrange the order? The commutative property tells me I can rearrange the order. And then from here to here, what did they do? Well, they regrouped it. It was 44 and 79. They wrote it as 56 and 44. What property tells me I can regroup it? The associative property. So from each step down is what you were doing. You were looking at the line above it to see what changed and what property tells me I can change it that way. All right, 48 and 50. Questions on those? Absolute values. Do your absolute values first. Then do your addition, subtraction across. Common denominator of 16. Then just add or subtract across. Question. So let's look at this one. We're going to get a common denominator. Our common denominator here is 16, right? All three of those numbers go into 16. So I'm going to multiply the top and bottom here by 2 to get 16 there. 3 times 2 is 6. 8 times 2 is 16. Here I'm going to multiply top and bottom by 4. 4 times 1 is 4. 4 times 4 is 16. And I'm going to change just to plus a negative. It's already a 16. Plus a negative 11 over 16. You can just add across if you want to, or you can add the two negatives, but 6 plus a negative 4 is 2. 2 plus a negative 11 is negative 9. And that's where we're going to get our negative 9 over 16. Exponents are. The definition says for x is an element of the natural numbers 1, 2, 3, 4, 5. B to the x is the product of x factors of b. The repeated factor b is the base, and x, which indicates the number of times b is used as a factor, is the exponent. When numbers are written in this way, they are said to be an exponential form or exponential notation. So right here, this is exponential form or exponential notation. 5 is the base, 3 is the exponent. This is considered a power, 5 to the power of 3. All right? What it means is I'm going to take the base and multiply it by itself this many times. So 5 to the third power means 5 times 5 times 5, or 5 cubed. Base is my 5, exponent is my 3. So then you have some properties that happen when you start doing these. The first thing we're going to talk about is how to write it in exponential form. All right? I personally don't want to write that many 2's, so there's an easier way to write it. The base here is going to be 2 because that is what is being multiplied. The exponent is going to be how many times I write 2 or multiply by 2. In this case, if you count it up, you have 7 2's. So if I were to rewrite this in exponential form, I would say 2 to the 7th power. If I were to calculate what that is, I would actually multiply the 2's out, right? So what's the difference between that and b? Well, you'll notice b has a negative 3, and then they have a negative 3 in parentheses. These mean different things, all right? So when I'm multiplying something like this, these guys are technically taken to a power, and this is not in parentheses. Now, had this been a positive 3, this would look different. This is a negative 3, so technically you could just say, okay, this is the same thing. But you have to be really careful when you're actually doing properties with positives and negatives, all right? This negative 3 is used 4 times. So we would keep that guy in parentheses, and we would say to the 4th power. Why does it matter that I keep it in parentheses? Well, because there is a difference between these two things right here, all right? This first one, without the parentheses, this is actually going to tell me to do the 3 first. So you're technically saying negative 1 times 3 to the 4th. We just talked about order of operations, right? In order of operations, I would do 3 to the 4th first, which is 81. And then I would multiply by that -1, which would be negative 81. But look what happens when the whole thing is in parentheses. When the whole thing is in parentheses, that -3 is actually being taken. And I'm not sure why they keep leaving him out. We're going to put parentheses around him too. When it looks like this, I am literally multiplying -3 times -3 times -3 times -3. I am not doing the 3 to the power first. So if the negative is on the inside, then it gets taken into account how many times you multiply. Why does this matter? Well, we just did something with multiplication of positives and negatives. If my negatives are even, my answer is positive. If my negatives are odd, my answer is negative. So it makes a difference. All right? Here, my negatives are even. So my answer came out positive because it was taken into consideration that I was going to do it 4 times. But in the one above it, I actually only had 1 negative. It was not part of the exponent. All right? So that negative was not part of the exponent. You only had 1 negative, and you had 4 positive 3s. When it is inside parentheses, then it is part of the exponent, and you have as many negatives as you have exponents. So in the bottom case, I had 4 negatives, which made my answer positive. So it matters if that negative is in parentheses or not. If it is not in the parentheses, do the exponent piece first, and then apply the negative to your answer. If it is inside the parentheses, you do the negative along with it, and your answer will depend on how many negatives you have. Questions on that? All right, so let's look at this example. Evaluate these. Evaluate these. So this first one is 9 cubed. To evaluate it, I am literally going to multiply 9 times 9 times 9. All right? 729. This next one, -7 to the 4th power. That negative is actually in the group there. So is my answer going to be positive or negative here? Positive. I will have 4 negatives. So then I just have to multiply 7 4 times because I've already determined, and you can't talk and write at the same time, I've already determined that my answer is going to be positive. So I don't even have to worry about this negative at all. Once I multiply it out, I know that my answer is positive. All right? Look at the last one. Is my answer positive or negative?
Negative.
It's negative. That negative is not part of the exponent. So I technically have a -1, and I am multiplying it by 4 squared. 4 squared is positive, right? But when I multiply it by that -1, my answer is negative. So when I do properties of exponents, I actually like to do expanded form first, okay? So I'm going to give you examples, and then we're going to see why the examples work the way they do. The first product property is what we're going to talk about, meaning when your bases are the same and you are multiplying them. You'll notice my bases for both of these are x. My bases are the same. This rule says that if your bases are the same, you simply have to add the exponents, all right? So let's get an example of this. They've used x. So let's say I have x squared times x cubed. My property says that should be x to the 5th, but why? So I'm going to expand both of those out. How would I write x squared? If I expand it, how many x's would I have? 2. And that is being multiplied by x cubed. How do I expand x cubed? 3 x's. How many x's do I have?
5.
And that is why your product property works. All right? So you don't have to expand it every time, but if you did, this is what you would get. You would see a pattern that happens when you expand, With like bases, all you have to do is add their exponents when you're multiplying, okay? So the first rule is the product property. It says, if you are multiplying like bases, all you have to do is add their exponents, all right? Because that's how many you will have. Quotient property. The quotient property says that you subtract. Why does this work? So let's use the same type of example with expansion. So let's say I have x to the 5th divided by x squared. I am going to expand. I have 5 x's on top. And I have 2 x's on bottom. Now, what happens when I divide any number by itself? 3 divided by 3, 4 divided by 4, 5 divided by 5. What do I always get? 1. So here I have x divided by x. That's technically just 1. So I could say 1 times that and 1 times that, right? I have another set I can do. Another x divided by x, right? Now when I have a 1 in the denominator, it really doesn't change anything, right? 3 over 1, that's just 3. 4 over 1, that's just 4, right? So I can actually ignore those things in the denominator, 1s. In the numerator, I'm multiplying by 1s. Does that affect anything? No, my identity property says if I multiply anything by 1, I get what I have, right? So what do I technically have left over? Well, I have 3 x's left over, don't I? I've canceled out 2 of them. X cubed. My property says that if I had just done 5 minus 2, I would get my answer of x cubed. And you see that it works. It works because of expansion. All right? It works because of expansion. That is your quotient property. One more property, then we're going to actually do an example of these. Power property. My power property says that if I take a power and I raise it to another power, all I have to do is multiply those. Why does this work? All right, let's look at the same thing. We're going to say x squared, and we're going to take that to the 3rd power. What does that mean? That means everything inside of it, I'm going to do 3 times, right? So I'm going to say x squared times x squared times x squared, right? I already have a rule about multiplying bases. What can I do with all those exponents? I could have added them, right? 2 plus 2 plus 2, according to this property up here, right? 2 plus 2 plus 2. That sounds very much like 2 times 3, but that's 6, right? Which is the same thing as if I had done my property. That's 2 times 3. Power property. Power to a power. All right? Those are your first 3 properties. If you multiply like bases, add their exponents. If you divide, subtract. If you take a power to a power, you multiply your exponents. Those are your first 3 properties. So let's look at how those are applied. By the way, when I give you a quiz or a review, we will be doing it with variables and with numbers. All of these examples right here are with numbers, but I'm going to give you some later on in the week with all variables. All right? So they actually just want my answer in exponential form, which means if it's 5 squared, you don't give me 25. You leave it as 5 squared. It wants it in exponential form. We will move on, and as we do larger ones of these, I will have you expand them and actually give me the answer. But right now, it only wants you to leave it in exponential form. So let's look at A. A is same bases? Yes, they're both 5. We are multiplying them. What am I going to do with my exponents? Multiplying like bases. I'm going to add them. So 2 plus 10. So I'm going to have 5 to what power? The 12th power. That is my answer. See why I don't actually want you to give me the answer, because that's a ginormous number. All right. Look at B. What am I doing here? Multiplying like bases. What am I going to do with those exponents? Add them. 2 plus 4 plus 9. What do I get? 15, right? 3 to the 15th power. All right. Last one here on the top row, C. I am dividing. What does my property tell me to do with those? Subtract. If I don't see a power, what is the power? It's 1, all right? We'll talk about 0 power in a minute. If you do not see a power, your power is 1. If you do not see an exponent, it is 1, all right? So it tells me to subtract. That's 2 to the 4 minus 1. So it is 2 to the 3rd power. That's the only one I would actually expand there to 8, all right? D, what am I doing? I'm dividing. So what am I going to do with those? I'm going to subtract. 10 to the 5 minus 3, it is 10 to the what power? Second power squared. All right? And the last one, power to a power. What do I do with those exponents? Multiply them. 3 times 6, 5 to the what power? 18. The next property is called a non-zero number to the 0 power equals 1. All right, a non-zero number to the 0 power equals 1. So when x does not equal 0, then the power equals 1. All right, so why does this work? We're actually going to use expansion, and we're actually going to use division here. All right, so if I were to say x squared divided by x squared, my quotient property tells me I do what with those exponents? Subtract. I'm dividing, right? So I'm going to say x to the 2 minus 2. But what is 2 minus 2? 0. All right. When I expand it, I have x times x over x times x. What do these cancel to? 0. Anything divided by itself equals 1. So on the top, I have 1 times 1, which gives me, on the bottom, I have 1 times 1, which gives me 1 divided by 1 is 1. Anything to the 0 power equals 1. So when I actually give you instructions, they will say, leave your answer in positive exponents. 0 is not a positive number. Nope. Okay? And so we're about to do negative exponents as well. So you will always have positive exponents as your answer, which means if you have something to the 0 power, you need to change that to a 1. Not something to a 1 power, just the number 1. It reduces to the number 1. Okay? So you'll notice it is not x to the first power, it is just 1. Negative exponents. Negative exponents for any non-zero number x and an integer a. X to a, the negative a is the same thing as 1 over x to the a. Why does this work? We're going to use the same property, division property. So now let's say I have x squared over x to the 5th. My rule tells me to subtract here, right? So I'm going to say x to the 2 minus 5. What is 2 minus 5?
Negative 3.
Negative 3. Now this property is telling me that this is going to be 1 over x cubed. Why? Well, let's expand. On the top, I had x times x. And on the bottom, I have x times x times x times x times x, right? I'm going to use my cancellation method. If I cancel this x to this x, I have a 1 and a 1. If I cancel this x to this x, I have a 1 and a 1. On top, I have 1 times 1, which is 1. On bottom, I have 1 times 1 times x times x times x. How many x's do I have on bottom? 3. Any negative exponent is going to do this. It's going to reciprocate it. Any negative exponent is going to reciprocate it, and that is why. It's going to put it on the bottom to the positive power. So a negative power does not change your answer to a positive and negative. It just tells you where to put the base, okay? It did not change it to a negative x cubed. It just told me where to put the x cubed, where it is located, okay? So anything to a negative power is just going to reciprocate that base. It's going to take that base and reciprocate it and make it the positive power. And this is why. Because x to the negative 3, when I expanded this guy, you can see the negative just told me a place. Put it in the bottom to the positive 3. So it wants me to take these powers. The first thing I'm going to do is I'm going to say, all right, my negative is inside my parentheses, okay? My negative is inside my parentheses. And this is to a negative power. All right? So you could do this two ways. First of all, you can say, what would negative 2 be to just the fourth power? So what would negative 2 be if I just took it to the fourth power? Let's say I took negative 2 to the positive fourth power. What is that going to be? Positive or negative first?
Positive.
Positive, and it's going to be 2 to the fourth power, right? 2 to the fourth power. What is 2 to the fourth power?
16.
It's 16, right? So if I just had negative 2 to the fourth power, I would say 16. However, I had negative 2 to the negative fourth power. It's going to be the reciprocal of that. It's going to be 1 over 16. There is another way to look at it. You can reciprocate it first. So I can say, well, negative 2 to the negative 4 is the same thing as 1 over negative 2 to the fourth power. And then I can say, what is negative 2 to the fourth power? Well, that is 16. So this is going to be 1 over 16. Okay? So you can do it two ways. You can either go ahead and figure out what it would be to the positive power and reciprocate it, or you can reciprocate it first and then calculate it. The only reason I do it this way is because if you have a variable, you can't really figure out what the variable would be, right? And so I reciprocate it. This one is different. What's different about this one from the first one?
It doesn't have parentheses.
It does not have parentheses. Yeah, it's a different number, but the key here is that it doesn't have parentheses. So that negative is outside of this guy, all right? So which means I'm going to do the 3 to the negative 2 first, and then I'm going to apply a negative to my answer. And again, we can do it two ways. The first way, and I'm going to write the negative 1 out here, is I can say, well, what would 3 to the second power be? And then I can reciprocate that piece of it. All right? 3 to the second power is 9, right? So then 3 to the negative second power is going to be 1 over 9. Right? Make sense? And then I still need to account for this negative, right? So my answer is actually going to be negative 1 over 9. The other way you can do is you can reciprocate first. And sometimes I think that's easier, all right? I have a negative 1, and that's multiplied by 1 over 3 to the second power. Remember, the negative 1 is outside of the power, and that negative just takes it to the denominator, all right? And so now I have negative 1 times 1 over 9, negative 1 over 9. Okay? So the difference between the first one and the second one is I accounted for the negative within it. So sometimes it's easier to, at the very first start, say, is my answer going to be positive or negative? And then you don't even have to worry about the one that's in front, okay? So like here, I would immediately say, barring that negative 4, negative 2 to the fourth power is going to be a positive answer. And you see my answer was positive. B, this negative is outside. And my answer is going to be a negative 1 times a positive. My answer is going to be negative. So you can immediately start thinking at the very beginning, is my answer going to be positive or negative? And then just deal with the numbers. Let's look at one more example. This is what I meant by it may not always be a fraction. All right? This reciprocates it. It reciprocates it. Okay? I have a 6 to the negative 3 that is already in the denominator. So if it were to flip it, where would he go? To the top, okay? So if I had just 6 to the negative 3, that tells me to put it in the denominator. But if I start with 6 to the negative 3 in the denominator, that tells me to move him to the top, okay? So negatives just tell you where to move it. If it is in the exponent, the negative is not going to affect your positive or negative of the actual answer. What's in front will affect your positive and negative. But the exponent will never change positive and negative. It will only tell you where it goes. Okay? And so then I would say 6 cubed, 216, positive 216 in the numerator. This would be my answer. Whereas this one would have been 1 over 216. Same number, just in the denominator, okay? Does everybody understand the negative exponents? All right. Let's do one more example with these, and then we're going to do some problems, all right? Leaving each answer in positive exponential form, all right? So let's look at this first one. I am multiplying like bases, right? So I should add my exponents. What is -9 plus 7? 3 to the -2. Look at my instructions. My answer should be in positive exponents. It is not, right? So what do I need to do? What does that tell me? Where does that tell me to put that 3 squared? In the denominator, 1 over 3 squared. All right, and it actually says to leave these in exponential form. So you don't have to make that 9. All right, if it says simplify all the way, you would say 1/9. If it says leave in exponential form, this is exponential form, okay? All right, so that is my answer for this guy. Look at B. I am multiplying log bases, so I need to add my exponents. What is -3 plus -2? -3 plus -2? -5. So that is going to be 1 over that 2 to the 5th. Everybody see how this is working? Let's look at the next one. I am dividing like bases. What do I do with those exponents? Dividing, you subtract. -2 minus a -3. What is that? Yeah, it's plus a positive. So I actually end up with 4 to the +1, and I don't have to move it. It's already in positive exponential form, yes? 4 to the +1. And let's look at the last one. Power. I have a power to a power. What do I do with those? Multiply. 5 to the -3 times +4. What is -3 times +4? -12. Where does this go? In the denominator. 1 over 5 to the 12th. That negative just tells me the location. Power to a power. What do I do with those? Multiply. So 7 to the -2 times 3. What is -2 times 3? 7 to the -6. That's just telling me where to put it in the denominator. 1 over 7 to the 6th power. All right. This next one, power to a power. What do I do with those? What is -6 times 0? What is anything to the 0 power?
1.
My answer here is 1. And by the way, I didn't even have to do a power to a power. It doesn't matter how big the inside is. You could have this. You don't even have to work it out. If the entire group is to the 0 power, your answer is 1. All right, last one. All right, this one's a little bit tricky. All right, so here's the thing. There's 2 ways to think of this, all right? You could rewrite him first. So what is 8 to the -3rd power? 1 over 8 to the 3rd power times 1 over 8 to the 5th power. How do I multiply fractions? I just multiply across, do I not? So 1 times 1 gives me a, and then like bases, I'm going to do what with those exponents? Add them, 3 plus 5, which is going to give me 1 over 8 to the 8th. Or you could rewrite this second guy as the negative. So I have 8 to the -3 times, what is 8 to the 5th? I have someone already out. What is 8 to the 5th on the denominator? How would I write that just in exponential form? 8 to the -5th. And I add those, which is going to tell me to put it in the denominator. So 2 different ways to think about it. You can rewrite it to positive and then multiply across, or you can rewrite it to negative, multiply across, and flip it. All right?